Hey, hi everyone. So we are trying to solve the same problem that we discussed last time, finding the first and last position of the element in the sorted array. But this time we are trying to do two binary searches instead of doing a left scan as well as a right scan. And this time we will try to use the recursive binary search option, right? So we will first write the recursive binary search function. I'm just going to define a function called search, and so I'm going to pass through this nums, obviously, which is the array, the target, and I'm going to pass the left, the right, and I'm going to also pass a flag. So this flag is going to be called as first or last, right? So my idea is, um, let's say if I want to find the first element, I'm going to call basically this search function with all these values, nums, target, left, right, but I'm going to pass now first. Likewise, for the last element, I think it will be better if I call this maybe as position. So this is going to be first position, and this is going to be last position, and here I'm going to use the flag as last, right? Okay, so this is my idea of how this function is going to be. Obviously left, right, etc. has to be defined first, so let's do that first. Left to right is equal to 0 comma len of nums minus 1, right? All good there. And obviously this function has to happen below this, because this function has to be defined below. And then what we would return would be return first pose comma last pose. Okay, so now we have to basically implement the binary search and have a special flag which is first or last, and then based on that we would change things. Okay, so the first thing that we have to do would be the terminating condition for search is right should be greater than or equal to left, right? While that is the case, while right is greater than or equal to left, what we can do is we can get the midpoint. Mid is going to be left plus right, by 2. All good there. And then basically we now get into the point of checking whether the mid value is basically equal to the target, right? So if nums of mid is equal to target, right, then we should start looking at whether we have to find the first position or the last position. So here we will start looking at the flags now. Last equal to first. Okay, so if it is first, then what should we be looking at? We should be checking for, we should be going to the left of the mid value, right? And checking whether there are values which are actually matching the same value, right? If it is matching as the same value as target, then we should move the midpoint value, sorry, the left pointer value, not the left pointer, the right pointer value to mid minus 1, and keep doing it, right? Because we are trying to look at the left hand portion. But there will be obviously case where it is not equal to the target. So let me just write it so that it will be clear. So if first or last equal to first, then the next thing that we are checking is, yeah, we can do this inside a while loop. Oh no, we should not use while loop, we should use recursion. We can check if um, mid minus 1 is greater than or equal to 0, and nums of mid minus 1 is equal to target, right? If so, what should we do? We should actually make our right pointer is equal to mid minus 1. So what we are checking here, the first part of the condition is for ensuring that we would not be reaching a point where the array has, we'll be not crossing the left boundary of array. And then the second part is checking whether the previous element in that array is equal to target. If that is the case, then we make the right pointer as mid minus 1, and what we are doing afterwards, okay, so this is the right pointer, and there is going to be a case where if nums of mid minus 1 not equal to target, then we are just going to return mid, right? We are not done here, because what we have to do here would be, in the if clause we have to do another binary search with now right updated as mid minus 1, right? So this is basically another return search, same things, target, left, right, and whatever was the first or last. Now, yeah, this is the first case, right? So now the other case is elif first or last equal to last. So if it is last, then what we are checking for is basically the right hand path, right? Yes, trying to look at to the right side of mid. So here we are checking whether again we are crossing the boundary. How we are checking this is through this n of nums minus 1. This ensures that we will not get into weird index errors. And nums of mid plus 1 is equal to target. Well, that's the case. What we should do would be, we need to move our left pointer equal to mid plus 1, right? And then we should again call search with, this is becoming a little bit more verbose than the iterative solution, but I just thought, I want to master how the binary search would also work in a recursive manner. So yeah, so this is done. And of course, the else case of this is when nums of mid plus 1 is not equal to target. Then what we have to do is basically return mid, right? Okay, so what we have done so far is the base case. So this is all the things that we have done after finding the first target element. Now we have to do the conventional binary search that's required. So obviously what we are doing here would be we're checking whether the target is greater than nums of mid. That means we are looking at a number which is to the right hand side of mid. So we would have to update our left pointer equal to mid plus 1, and then we have to call the search again. Right, first or last. I think I'll just copy this for the next time. Oh, it's sad. Oh my god. Okay, so much for optimization. Trying to do things faster. Yeah. I'm using another keyboard, which is why it's slightly weird for me. Hmm. Please bear with me for this. Okay. Now, yeah, I can put it under else, but I'll just ensure that it goes under another relief. This is obvious right now. What we have to do is make it right as mid -1. Then we have to call again search. Um, okay. So yeah, so there is another case where the element is not found within the search option. So that is when we cross over the first if, that is if right is greater than or equal to left. There has to be an else here which returns it as -1. Okay, so yeah, I guess we have the code. Let's just try it now. Okay, this case passed. Let's submit. Okay, I think I have some error here. Let's see what it is. Okay, I have an index error, and the example here is when there is just one element. Oh, when there is just one element, then there is obviously no. Okay, I think I can just handle all of this by just doing else. Yeah. Even this one, I don't probably have to. Check for that index, because I know that if this is not the case, I can just return else. I don't have to get into, because yeah, the mid -1 has already been updated there, right? So I don't have to check like this. Yeah, let me try. Hooray, that worked. Yeah, and this is much faster than the previous solution. So just to look at the solution again, sorry about that. Yeah, so let's look at it. So we have basically a recursive binary search. We are doing it for fun. And then so this is the crux of the logic, right? Basically what to do once we have found the element, right? So here we basically have flag. This is the flag for finding the first position, and this is basically the flag for finding the last position. So what we are doing is like checking whether if the previous value for the case of first position, we are checking whether the previous value is still equal to target. So then we are just updating the right as mid -1 and again doing a search, right? So eventually it will not be equal to target, which will come to basically else, right? In that case, we'll just return the mid value. That's what we will do. And likewise for last position, it's basically you have to look at the right side. So that's why we are doing nums of mid +1, and then we are going through this approach. Yeah, and then obviously this part is basically the conventional binary search. So yeah, I don't have to explain much on it. And then this is basically the return for when we don't find the element, what do we do? That's what we have here. We call the recursive binary search twice, one for finding the first position and the other for the finding the last position. So each of this we can say that it's going to be O log n plus maybe another O of log n, which would come to still O log n, which is